Okay, today I'll be explaining the Rydberg equation. So what are the three Rydberg equation constants? Well, unfortunately, chemistry is not kind to us. We don't just have one constant. However, there's a simple way to figure out, based off the wavelength constant, what the other two, the frequency and the energy constants, will be. So, the wavelength constant is 1.097 times 10 to the power of 7, parentheses 1 over n squared over 1. That 2 over 1, honestly, there shouldn't be a little, that's just 2 divided by 1. This is n squared, first term squared, minus 1 over n 2 over 2. So, this is the first equation. This you have to memorize. I mean, you can memorize the other ones and then off those figure this out. However, I feel like this is the easiest one to memorize because if you remember that this is 1 over wavelength, you'll be fine for everything else. But, so this is for wavelength. Let me write this somewhere. Oh, I'm already jumping ahead. Wavelength. Alright. Now the second equation is for frequency. And personally, I just memorized this. However, it's super simple to just solve for it. So it's going to be 3.29 times 10 to the power of 15 over seconds. Oh, I forgot there should be meters right there. That's 1 over n. Same exact thing. No over that. Oh my gosh, I'm messing up. So, how do you figure out, how do you go from here to here? This part to this part. Well, you take 1.097 times 10 to the power of 7 and you multiply it by the speed of light. Okay, the constant for the speed of light, which is equal to 3 times 10 to the power of 8. And once you get that, once you solve that, you get 3.29 times 10 to the power of 15. And obviously, speed of light, it changes to over seconds instead of over meters. Okay. Now, that's for frequency. Now, how do we go from frequency to energy, or change in energy? We'll just do energy for now. So the change in energy is 2.180 times 10 to the power of negative 18. And the same thing right here. How do you go from frequency to energy? You have to multiply it. So you go 2.18 times 10 to the power of negative 18, just like we did before with wavelength. Oop. You have to multiply it by Planck's constant, 6.626 times 10 to the power of negative 34. And the answer to that would be 2.10 or 2.18. Oh, gosh. Okay, I messed up. We gotta go back. There. If you haven't noticed, this is my first time doing this, so I'm not going to be the best. Okay, sorry. It's 3.29 times 10 to the power of 15 times Planck's constant, which is 6.626 times 10 to the power of negative 34. That equals 2.18 times 10 to the power of negative 18 joules. Don't forget the joules, just like I did right there. Ooh. So, so that is for energy, and you could say of a photon. And that's it. I mean, you just have to, honestly, I think it's easiest to remember just every single equation, because it just takes too long when you're plugging stuff into the calculator, and while you're mid-exam, it just is, it's time consuming. So it's just easier to remember off the top of your head and not have to look back at, you know, the the equation sheet that they give you, if they even give you one, or just plugging it in and having to do all the extra steps. I just think it's, you have to remember all of these. And also, an important thing to remember for wavelength, you have to remember that it's 1 over wavelength. It's not just wavelength. So whatever you get for this part right here, you have to do this like under 1. So that goes under 1. So 1 over that, and that will equal wavelength. So just take that into account, remember it, and don't mess up. Alright, now that we know the basics of the Rydberg equation, now let's just do a little practice problem, because there's not much more to get into. So we are going to practice. Alright, what wavelength, let me get the thing. What wavelength in nanometers? Okay, this is crucial to remember, because this is where I've messed up a lot of times, a lot of students mess up a lot of times. So I'll get back to that in a second, but this in nanometers, super important to remember. So what wavelength in nanometers must a photon have in order to excite the electron in a hydrogen atom? I mean, it doesn't really matter that it's hydrogen, because they're all gonna, Rydberg equations have to be hydrogen atoms, but yeah, from n equals 2 to n equals 1. Okay, so it's wavelength. So we have to do the equation using 1 over wavelength equals, and we remember from last time, it's 1.097 times 10 to the power of 7, and then 1 over n2 over, not over, 2, 1 minus 1 over n2, 2. Alright, so that's our equation. Now we have to plug everything in, because this is a constant, so we should already know this. And that we're solving for. So we just really have to plug in the first n term and the second n term. And this is super important to remember as well. It should always be, the first term should always be the smaller number. So that should always be n1. And the biggest number should always be n2. Now, why is that? It's because when you're subtracting a number that's being divided by, when you subtract a bigger number by a smaller number, it's always going to be positive. So by keeping the smaller n first, that helps keep the equation positive. And I mean, they're both going to come out to the same thing. It's just more work if you put the bigger number first. So let's get into it. 1 over that times 10 to the power of 7 over 1 over, and then it's 2, so 2 squared minus 1 over 6 squared. And I mean, we have everything we need to solve. So let me just get my calculator out. So we have 1.097 times 10 to the power of 7 times, in parentheses, 1 divided by 4, 1 over 2 squared, minus 1 divided by 36. And that's 1 over 6 squared. Alright. So I got a big number, and at first it's gonna, I mean, I don't know if it'll scare you or not, but shouldn't. So we're going to divide that number because, remember, it's 1 over wavelength, and we have to have just wavelength. So we have to do this whole thing. So whatever we get for this right here is what we put under 1. So wavelength equals 1 over, and then I got 2, 4, 3, 7, 7, 7, 7 G's. 0.77. Okay. Could be 7, 8, whatever, didn't round. Let's do that right now. 1 divided by that. So I got, that equals, oh, I hate that. That equals 0.000, oh geez, 0.00041. So at first you're gonna be like, wow, that can't be the answer. But like I said at the beginning, and it's a crucial step, this is in nanometers. This right here is in meters. This whole thing is over meters. So that's 0.00000 whatever 41 meters. Now this is, you have to remember the conversion, just conversion factors. So nanometers is 10 to the power 10 to the power of 9. Okay, I could make another video in the future about all the conversion factors, because this is like knowledge you should already know going into chemistry. However, if you don't, here it is. So it's nanometers equals meters. So we're going to multiply this answer times 10 to the power of 9. And when we do that, we get 410. And that is an answer I'm satisfied with. 1 nanometers. Because wavelength is typically, it's like less than, it's like normally they're around like 200 of 700, and they're always in nanometers. So this is something I'm happy with. I'm sure this will be an answer. I'm sure this will also be an answer. So that's why you have to be careful, because if you're going fast while you're taking the test and you just you skip over in nanometers, you're going to circle the first answer you get, and it's not going to be the right one. So just remember, take your time and solve correctly. Good luck. Okay, here's the second problem that I have. This one's going to be a little harder, so rewatch it if you need to. I'm going to try and explain as best as I can. However, no guarantees, but let's go. Let's try this out. So, an electron in a hydrogen atom, again, that doesn't really matter, falls to a ground state and gives off, okay, here, ground state. This is a word you need to remember as well. Ground state is N equals 1. Okay, always remember that. So, an electron in a hydrogen atom falls to the ground state and gives off a photon with an energy of 1.94 times 10 to the power of negative 18 joules. What energy level did the electron fall from? Okay, so what we're solving for, so this we know, this is the smallest number we can have. This is ground state. This is the lowest state that an electron can be at. So we know that N1 equals 1. Okay? N2 is what we're solving for. So we already have, this is the energy that the photon gave off, and we know the Rydberg constant for energy. So let's plug everything in. So energy equals 2.18 times 10 to the power of negative 18 joules. 1 over and blah blah blah, all this boring stuff. Alright, so we have that. This is the constant. This is the equation for energy. So now let's plug everything in. 1.94 times 10 to the power of negative 18, and then that's joules, equals 2.18 times 10 to the power of negative 18 joules, and then this as well. So in order to solve this, we need to work it out algebraically. So let's do 1.94 times 10 to the power of negative 18 joules over, because we're trying to isolate this second in term variable, we have to move everything to the right, over 2.18 times 10 to the power of negative 18 joules. So that's going to be equal to, when I pull my calculator out, so 1.94 times 10 to the power of negative 18, times 10 to the power of negative 18 equals, I keep messing this up in my calculator, that divided by 2.18 times 10 to the power of negative 18. So that equals 0.8899, and then the rest doesn't matter, we can cut that off. So we have 0.8899 equals 1 over, and because we know that the first n term is 1 over 1, we don't even have to write all that out. We can just say 1, because 1 divided by 1 is 1. So 1 divided by 1 over n squared, and then you don't have to write the over 2 thing. That just kind of complicates things a little more, and we don't need that. So this is what we have so far. So what I'm going to do is subtract this by 1. So 0.8899 minus 1. That gives me negative 0.1101, and that equals negative 1 over 2, or 1 over n squared. So we can cancel out these negatives, so we have 0.1101 over 1 over n2. Now, you can work this algebraically from here and just do times n squared, get that there, and then, but you can just flip these. So we're going to do n squared equals 1 over 0.1101. So let's just do 1 divided by 0.101, and we get n squared equals 9.08. And when you take the square root of n squared and you take the square root of 9.08, you don't exactly get 3. However, it is close enough to just say it's 3. Okay, it doesn't have to be like an exact, like, oh, it's going to be 3. Sometimes it will be. However, in this case it's not. So we know that the answer to this is n equals 3.